Hi guys, today we're going to learn about derivatives and then derivatives of, but we're going to use chain rules. So as you can see that in Calculus 1 you could do it, there's many types of styles of derivatives. So the one style we're going to do is chain rule. In this section I will go over what is the chain rule. I will derive using the chain rule, and then in order to do the chain rule you must know how to do the product rule, power rule, and the quotient rule. Okay, so let's do chain rule. So the chain rule is one of the many techniques of calculus using it calculus differentiation. So, oops, let me just do this. So one way to do the chain rule you could do is dy over dx is the same thing as dy over du times du dx. So if you don't know that way, you could do it this way. The derivative of the chain rule, you could think of it as f prime of g of x times by g prime of x, or you could think of it as the chain rule as a derivative of the outside function leaving inside the lone times it by the derivative of the inside function. Or you could just simply think of it as the derivative y prime is f prime of u times u prime. So this is probably the most popular way to think of it. So for an example, you would use the chain rule when you have something like this. You have an f, which is the cube root, and then your u is anything inside the function, which is this u is going to be the x plus 2. So how do you know when to not use the chain rule? So an example of when not to use chain rule, you're going to have y equals x squared plus 1. You're not going to use the chain rule because you're just going to use the simple power rule, right? Not the chain rule. Yeah, so when you have y equals 3x plus 2 or y equals x plus 2, you're not going to use the chain rule. Chain rules are just like something you'll see what I mean by when to use chain rules. So here are examples. So when using chain rule, you must know the power rule, product rule, and quotient rule. So here's a little review. You can like press pause to write these formulas down. Oops. So the power rule is xn prime is equals n times x minus 1. So an example would be like 5x squared. You times the 5 and the 2, which is 10, and then this 2, you always subtract 1 power, so it's 2 to the minus 1, which is 1. So that's power rule. Quotient rule is like you could use uv or f of g, which is you take f prime times by g and then plus g prime times by f. So that's the product rule. The quotient rule is simply you can use u or v or f and g. So you take the f prime times by g minus f times g prime all over g squared. Or you could use u and v, same thing, right? V times u prime subtracted by u times v prime all over v squared. So those rules comes in handy when you're going to use the chain rule. So I think we're going to do exactly 6 examples. So I'm trying to make these videos less than 40 minutes. So the first example says find y prime for this, y equals x squared plus 1 times by cubed. So we're going to use the chain rule. So yeah, the chain rule. So I could use, remember the chain rule is y prime equals f prime of u times it by u prime. So first I'm going to use power rule. Then take the derivative of the inside function. Then take derivative of inside function, or the u prime, right? So first use the power rule. So y prime is, bring this down in front, so it's going to be 3 times x squared plus 1, and then it's 3 minus 1, which is 2, so this is going to be the second power, and times it by u. We know that u is, it's always what's inside the function, so it's going to be x squared plus 1, and then u prime is just 2x, right? 2x minus 1, it's just 2x, so it's going to be 2x. And when you simplify it all out, you get y prime equals 6x times it by x squared plus 1. And then don't forget to square this. So this is your final answer. So yeah, for this one, it's a simple one. I just had to use the power rule. And then I know that my u is x squared plus 1, and then I took the derivative of that, and then clean it up, and this is how I got that one. Example 2 says find y prime. Okay, so this is involving radicals, right? Radicals. Yeah, this is involving radicals. So I gotta find the derivative of this, but let's see here. Before I do that, let's simplify this. How can I write this in power rule? I'm gonna rewrite it as in power rule, so I'm gonna rewrite it as I'm going to rewrite this as power rule x squared minus 1. There's a 2 here, and then there's a 3 here, so it's going to be raised to the 2/3 power. Right? If this was a 1 over here, it'd be 1/3, you know. Okay, so now I put in power rule, and then I got to find my u. What do you think my u is going to be? It's always inside the thing, so it's going to be x squared minus 1. So yeah, let me write what I'm going to do. So first I got to use power rule. And then I'm going to use, and then I got to find u prime. So power rule. So remember, we got to take the, first I got to use the power rule. So it's 2/3 times it by 1. So it's 2/3. We leave this the same for right now, x squared minus 1. And then it's 2/3 minus 1, right? Our new power is going to be 2/3 minus 1, but I can rewrite 1 as 3 over 3, right? So 2/3 minus 1 is negative 1/3. Negative 1/3, and then times it by u. So we got to find u prime. So u is x squared minus 1, so u prime is 2x. And then, you know, the derivative of constants is just 0, so it's just 2x. Let's clean it up. So this becomes 4/3 x times it by x squared minus 1. Raise it to the negative 1/3. Okay, so what do I do next? Let's clean it up. This negative 1/3, I want it in positive exponents, so I can rewrite that as this stays the same, so it's 4/3 x times by 1, and then I want this in positive exponent, so I'm going to put this in the denominator, so it's going to be x squared minus 1 raised to the positive 1/3 power. This simplifies as 4 over x over 3, so it's 4/3 raised to the x squared minus 1 raised to the positive 1/3 power. So, but what if I want it in radical form? So my final answer in radical form would be y prime equals 4x all over 3. So this in radical form, remember 1/3, we could rewrite that as the cube power. So cube, this is a cube, and then it's just x squared minus 1. So yeah, here's your final answer. Yeah, so for this one I had to use the power rule, and then I had to find u prime. Yeah, so remember, x to the 1/3 is the same thing as cube root of x, or what about x to the 2/3? It would be cube root of x to the second power. So that's just something you should remember. Okay, that one was example 2. Let's do example 3. So this one is involving quotient and constant numerator. So we got to find y prime. So I'm going to rewrite this as, what am I going to do? So I'm going to put this, I will rewrite this as negative exponents. So how would I write this in negative exponents? So I could rewrite this as -7 2t minus 3 raise it to the negative second power, right? I'm going to put everything in negative exponents. Yeah, because then I can use the power rule. So I gotta use the power rule, and then I'm gonna, what is my u? It's always inside, so it's gonna be 2t minus 3. So first use the power rule. So it's -2 times it by this -7, the coefficient. So that's -2 times -7, which is positive 14, right? 2t minus 3. And then remember the power rule, you have to subtract 1 from this, so it's -3. And times it by u prime, which is just regular 2, right? Now let's clean it up. 14 times 2 is positive 28. 2t minus 3, raise it to the -3rd power. But what if I want it in positive exponents? So my final answer in positive exponents is going to be y prime is 28 all over 2t minus 3 raise it to the positive 3 power. So I put this -3 into positive power, so if you get confused, so remember, an example would be, what if you have x to the -3 and you want that in positive power? It's going to be 1 over x to the positive 3. So keep that in mind, because that's how I got this answer. So that was example 3, right? Let's do example 4. I think I'm going to do 6 examples. So let's say you got to find y prime. This one's going to be a longer one. I'm not going to lie. So for this one, I'm going to put everything in power form. Yeah, that's my first step. I put everything in power form. And then I'm going to use the product rule for this one. I'm going to use the chain rule, but in order to do the chain rule, you got to use the product rule. So remember, product rule is f prime of g plus g prime of f. So first step, put everything in power rule. So it's going to be y equals x squared. That's square root is the same thing as 1 minus x squared raised to the 1/2 power, right? So now, let's see here. Okay, yeah, first, we gotta find we gotta use the product rule, right? We want to find y prime. So we gotta find, this is like my f and this is my g, so I gotta find the product rule. So we said that f is x squared and g is 1 minus x squared raised to the 1/2, right? So first, let me find f prime. So f prime is 2x. And then g prime, remember, for this, must use power rule and chain rule if you want to find the derivative of this. So first, let's do the power rule. So 1/2 times 1 is just 1/2. 1 minus x squared. And then 1/2 minus 1, we can rewrite 1 as 2 over 2, right? So that's negative 1/2. So this is raised to the negative 1/2 power. And then you have to take the derivative of the inside, or u, which is just negative 2x, right? Negative 2x. Let's clean this up. This is going to be negative 2x, or 1 minus x squared to raise it to the 1/2. Let me think. Let's see. Oh, this simplifies as negative x all over the square root of 1 minus x squared. Okay, so let's see here. So we found the f prime and we found my g prime. So we're going to use the product rule. So it's f prime times g plus g prime of f. Let's use the power rule. So yeah, power f prime of g plus g prime of f. Okay, so y prime is f prime, which is 2x, right? Right? F prime is 2x, times it by g, which is 1 minus x squared raised it to the 1/2, plus g prime times f. So g prime is this thing. So it's negative x over square root of 1 minus x squared times it by f, which is just, what is f? Well, f prime is 2x, so f is x squared. Let's see here. This one looks really, really weird. So when we clean this up, this is going to be plus negative x cubed over 1 minus x squared, and then this is going to be 2x times it by square root of 1 minus x squared, right? Because 1/2 is the same thing as square root of that. The reason why I'm putting in square root because I'm going to multiply it by the common denominator. So this is there's a 1 here. So what is my common denominator? Because we're adding fractions, right? What is my common denominator? My common denominator is square root of 1 minus x squared. So I got to multiply top and so over here I don't have to do anything here, but over here I have to multiply top and bottom by square root of 1 minus x squared, square root of 1 minus x squared. Okay, good. So what happens when you multiply the square root of something? The radical just disappears, so you're just left with the inside 1 minus x squared. And then don't forget about this 2x plus this one we didn't do anything, so it's just plus negative x cubed all over square root of 1 minus x squared. Okay, so let's simplify this. So 2x times 1 is 2x, and then 2x times negative x squared is negative 2x cubed, and then plus a negative x cubed all over 1 minus x squared. Let's see if we can clean this up. I think we can. What can I do here? I can factor out an x. If I factor out an x on the numerator, I get x times 2 minus 3x squared, and then you're left with the bottom's just square root of 1 minus x squared. So your final answer is y prime equals x times 2 minus 3x squared divided by, or by the whole thing by square root of 1 minus x squared. So that's your final answer. So that was 7. Okay, 2 more examples. So hopefully I can make this under 40 minutes. So first we got to find y prime. So we have the radical again, example 5. For this one we're going to use quotient rule, and then we're going to use product rule. So let's see, what am I going to do here? So product rule, remember, is u over v prime, or f over g is the same thing, u prime v minus u v prime all over v squared. Or you could use f and g, it's the same thing. So let's see, first stop is, I'm going to use the quotient rule. So the quotient rule, so first I got to find my u and v. So my u is x, this is my u, and then this whole thing is my v, right? So u is that, and then v is cube root of x squared plus 4. If you take the derivative of that, you're going to get I'm not going to do the work. So when you take the derivative of this, you're going to get 2x over 3 times by x squared plus 4 raised it to the third power. So basically you got to use, I put this in x power form, and then you're going to use power rule and the chain rule, right? X squared plus 4 raised it to the 1/3. You got to use the power rule, and then you got to use the chain rule, and then you would get this part, this. You got to, so v prime, and then you got to find v square, right? Yeah, you got to find v square because we got to use, yeah, we're going to use, this is the quotient rule. So you got to find v square, so it's x squared plus 4 to raise it to the 1/3, and then you got to square that, so that's going to be v square is when, remember, raising it to the power, you're going to get 2/3, so it's going to be cube root of x squared plus 4. And then we didn't know what is u prime. U prime is just 1. So we're going to use the quotient rule, u prime times v minus u times v prime all over v squared. So when you put it in the equation, this is what you're going to get. You're going to get y prime equals x squared plus 4 raise it to the 1/3 power times it by u prime, which is 1, minus, and I'm going to put bracket because it means I have to distribute that negative. So it's u times v prime, which is x times 2x times it by x squared plus 4, raise it to the negative 2/3, all over v squared, which is x squared plus 4, raise it to the 2/3 power, right? This cube root is the same thing as cube root power. Yeah, I didn't put it. I should put a square right here. Okay, so now what I do is I can actually factor out something. I can factor out a 1/3 x squared plus 4, raise it to the negative 2/3 power. And when you factor that out, you're going to get 3 times x squared plus 4 minus 2x squared times it by 1 all over x squared plus 4, raise it to the 2/3, and then make sure you bracket that out. So when you factor that out, you're going to get, when you FOIL this out, you're going to get 3x squared plus 12 minus 2x squared. And then remember this negative 2/3, and then you have a 2/3. So you're actually dividing it. And remember, when you divide exponents, when you're dividing exponents, you're really subtracting. So it's like saying negative 2/3 times minus 2/3. I get negative 4/3. So that's why I get x squared plus 4 raise it to the negative 4/3 power. So when you do all the work, you're going to get y prime equals x squared plus 12 all over 3 times x squared plus 4 raise it to the 4/3 power. So this is your final answer. Okay, and then my last example, okay, example 6. they can finish it. So this one we're going to have to use the power rule, and then we're going to have to use the chain rule, and then we're going to use the quotient rule. So let's see here. First use the power rule. So y prime is 2 times this thing, 3x. This stays the same, right? X squared plus 3. And then 2 minus 1 is 1. And then you got to find u prime. Remember, u is this whole thing, 3x minus 1 over x squared plus 3. And then to find the u prime of that, you got to use the quotient rule. So when you do the quotient rule, when you find, so this is the quotient rule, so this could be my f and this could be my g. So when you do the work, when you take that, you're going to get, what am I going to get? I'm going to get, you're going to get, so let's simplify. So it's 2 times 3x minus 1 over x squared plus 3. And then it's u prime, and u prime is 3 times x squared plus 3 minus, how I got the minus, I'm using the quotient rule. So it's going to be minus bracket 3x minus 1 times it by 2x. And yeah, so how I got this all over x squared plus 3, raise it to the second power. How I got all this is I use the quotient rule. When you use the quotient rule, this is what you're going to get. So when you simplify, let's see, simplify. When you simplify, you're going to get this. 6x minus 2 times it by 3x squared plus 9 minus 6x squared minus 2x divided by the whole thing by x squared plus 3, raise it to the third power. How I got the third, here remember we got an x squared plus 3, so that's like saying 1, that power has a 1, and then you're dividing, so it's 1 minus 2, which is, wait, yeah, so wait, no, that's wrong. How I got, when you do the work, you're just going to get positive, negative 3, which is the same thing as putting it down in the denominator. So let's fix the numerator. When you multiply it out, you're going to get, on the numerator, you're going to get negative x cubed minus 12x squared plus 54x plus 6x squared plus 4x minus 18 all over x squared plus 3 raise it to the third power. And then when you simplify it, you're going to get, so your final answer should be y prime equals negative 18x cubed minus 6x squared plus 58x minus 18 all over x squared plus 3, raise it to the positive 3. So this is your final answer. So yeah, this is, we are deriving using the chain rule. So this wraps it up for this section.